Hello class, this is test 1 review. So before I begin, there's a few facts about the test I wanted to write down. So it's on September 22nd, and it will be open from 8 a.m. until midnight on that day. But once you begin the test, there is a 75-minute time limit. And you take the test online on the Pearson website where you do homework. There will be 15 questions. So a good way to study is to do all your homework, because then you will be familiar with both the material and the Pearson software. So what I'm going to do for today's review is just a few practice problems that are similar to the test problems. So let's begin. So first we should be comfortable solving an equation for x. So what I mean by that is, say we have an equation like, I don't know, 3x, 2 minus a. I don't want to do another x there. Sorry about that. Let me rewrite this equation. 3 times x minus 2 equals 2x plus 1. Okay, solve for x. Okay, so if we do this, remember how to multiply through the parentheses. We do it like that. It becomes 3x minus 3 times 2, so 6. 3x minus 6 on the left-hand side. And I'll just copy down the right-hand side. Okay, and then what we do is we combine like terms. So I'm going to put everything with an x on one side of the equation. I'll put all the numbers on the other side of the equation, right? And then we get the following. 1 times x, or more simply just x, equals 7. So it's not too bad. Hopefully we are all comfortable with that. The next thing I wish you will be comfortable with is finding the domain of a function. So let's be given a function f of x is 1 over square root of x plus 1. And let's find the domain of f. Okay, well, remember domains, I gave you a few rules. So again, the domain is all the x values we are allowed to plug into the formula. And we got to be careful with a few rules. We are not allowed to plug a 0 onto the bottom. And when we're dealing with functions here, we don't want to plug in negative numbers into the square root. So this function has a bottom and a square root in it, so we have to be careful with both of those things. So I'll say since x plus 1 is in a square root, we request that x plus 1 be greater than or equal to 0, or more simply, x greater than or equal to -1. That's one of the conditions. But we also have another condition. Since, let me say, since the square root of x plus 1 is on the bottom, well then it cannot equal 0. Right? And that is to say x plus 1 cannot equal 0. Right? So x cannot equal -1. So now we have to take the overlap of both of these conditions. So the first condition was x had to be greater than or equal to -1, but our other condition says, well, we can't equal -1, because then that would break another rule. And therefore, when we consider both of those at the same time, we find that the domain of f is given by, well, x strictly greater than -1, right? Or in interval notation, we'd say -1 to infinity. So hopefully that made sense. Another thing we need to be able to do is the following question. So say we're given a formula for f, I don't know, maybe 2x plus 1. We're given a formula for g, which is x squared minus 1. Let's find g of f of 1. Well, what this means is that first we plug the 1 into f, and then we take that output and plug it into g. Right, so f of 1, when we plug 1 into f, we get 2 times 1 plus 1, that equals 3. So we take this 3, and now we plug it into g. So g of 3 is 3 squared minus 1, that's 9 minus 1, and that is 8, which is the answer. Not too bad. This was an example of plugging in a number into what is called a composite function here. Also be comfortable with the domains of composite functions. I'll let you watch the video lesson if you have not seen that yet, to refresh your memory on domains of composite functions. Okay, let's turn our attention to a new example. Okay, here's a function. Let's call this function f. Okay, let's find when f is increasing, constant, and when it is decreasing. Well, again, we read this from left to right, so we think of this as the increasing part, same way here. This is the decreasing part, that's the constant part. So how we specify the location is we talk about the x values for which it's decreasing, increasing, or constant. So f is increasing at negative infinity to negative 2, or from 2 to infinity, and you can see that from the graph. When x is negative infinity to negative 2, the corresponding graph is increasing. When x is 2 off to infinity, the graph is increasing. Okay? F is constant at negative 2 to 2. As you can see from the graph, when x is here, the graph is constant. Okay, lastly, we have f is decreasing just from 1 to 2. Right? So as you can see, x is 1 to 2, that's when the graph is decreasing. Okay. Another thing I want you to be comfortable with is odd functions and even functions. So again, let me remind you the property. In an odd function, when you plug a negative number in, the negative number can be pulled out. When you plug a negative number into an even function, on the other hand, the negative cancels out and you are left with the original function. So I'll just give you a few examples and you can plug these properties in at home to practice. X squared is an even function. 4th plus 2 is even, say x cubed, x cubed minus x is odd. X cubed minus x to the 9 is odd. So some examples, so you can plug into those at home. Basically, if you plug in a negative here, the negative will cancel out because it got squared. Negative will get canceled out here because it's to the fourth. But in these, the negatives get preserved and you can pull the negative out. So practice your corresponding homework problems with that stuff. Another thing we should know, this goes way back, the distance formula. And that was one of the first lessons. Distance and midpoint formulas. So remember those ones. I'm going to do a quick example. Let's say the distance between, I don't know, 1, 2, and 3, 4 is, well, the formula is big square root, and you do x1 minus x2 squared plus y1 minus y2 squared. So this was x1, this is y1, this is x2, this is y2. Oh, I forgot the squared here. Okay. So what do we have? 2 squared is 2 squared. So 2 times 4. Okay. Okay, so let's also be comfortable plugging into piecewise functions. So let me give you a piecewise function. Okay, so if we plug some numbers in, let's say we plug in the number -3, that's going to equal 3. Why? Because -3 is less than 0, so therefore we plug into this formula. Okay, well, what if we plug in +3? Well, +3 is greater than 0, so I plug into that formula. And by coincidence, I also get a 3. Right, f of 4 would therefore be 4, right? Because 4 is greater than 0, so I plug into this formula. Okay, what about f of 0? Well, that will equal 1. Why? Because 0 obviously equals 0, so I plug the 0 into that formula. There really is no need for the x there, but it's okay. Yeah. And then the domain here is all real numbers because it's given right here, just in 3 pieces. Okay, now let's maybe look at a few inequality problems. Let's do -3 less than or equal to 1 minus 2x less than or equal to 15. So if you see an inequality like this, the goal is to sandwich the x in the middle. So let me minus 1 to all 3 sides, and I have -4 and equal to -2x less than or equal to 14. Okay, now I could divide -2 to all sides, but if I do that, I have to flip these symbols. Remember that property. So now we get +2 greater than or equal to x greater than or equal to -7. Or it's more natural to put the small number on the left and the big number on the right. And in interval notation, we have -7 to 2. Or on a number line, -7, 2. We have these numbers. So let's be comfortable with that stuff. I did mention the midpoint formula. I'll let you review that at home. It's pretty easy. I didn't do an example though, but it's okay. Well, I'll do an example here. It's not too bad. The midpoint of 1, 2, 3, 4 is, well, by the formula we add the x values, cut it in half, add the y values, cut it in half, and that's all. So we have 4 over 2, and we have 6 over 2, so we have 2, 3. Okay. So that's pretty much the only concepts. Well, I guess there's one more thing you should be comfortable with, and that's, say you're given a function, g of x is, I don't know, x squared plus 1. Just be comfortable plugging things in. So an easy thing is if you just plug a number in, hopefully you're comfortable with that. But we could also plug in other symbols, so plug a t in, and we get t squared plus 1. You know, we plug a smiley face in, we get smiley face plus 1. Right, we could also plug in a complicated thing like t minus 1. And then we just do t minus 1 squared plus 1. So just be comfortable with that concept. Pretty easy concept, but sometimes people make mistakes with that. And lastly, maybe review your homework on the word problem section, or you could review the video lessons there. So that is about what you should expect on this test. So it is important to study for it in more detail than just this video. This video is sort of a map of what you can expect, but definitely not enough to prepare you. You need to do a lot of work on your own, so practice the homework, and you could practice similar problems as in this video. You know, find similar problems in the book or online. And as always, if you have any questions, feel free to message me. Okay, thank you.